Good morning students, welcome to physics class. In the previous lectures, we have covered applications of dimensional analysis. Today, we have to do few more numericals but on the basis of principle of homogeneity. Usually, as per principle of homogeneity, dimension formula of the relation on left side and right hand side must be same. But now, today, the numericals which we will solve, which we will practice, that will based on the concept that the relation is dimensionally correct and we have to find dimension formula of some unknown factors. So, let's see the statement. Write dimensions of A and B in relation P equal to x square minus B upon AT, where P is pressure, x is distance and T is time. So see, this is a statement where pressure is x square minus B upon AT. Now, here we are familiar with dimension formula of all the terms. So first of all, dimension formula of pressure M, you can just check it. This is force per unit area. If you have confusion, you can check it. This is force is mass into acceleration ml t minus 2 upon area L2. So you can calculate ml minus 1 t minus 2. So it is ml minus 1 t minus 2. Now dimension formula of x. X is distance, so it is L. And for time, this is T. So you can see here now dimension formula of each the term used in the formula is known to us. Now how to solve it? We know that as only like quantities can be added or subtracted. So as you can see in this numerator, there is a term x square minus b. So what is the dimension formula of these two? As x square will have dimension formula of L ki power 2. So the difference of these two must have dimension formula that should be L2. Because x is having formula L, x square will have L square. So x square minus b, it must have formula L ki power 2. It means dimension formula of B is, this will be same, it will be L ki power 2. So this way you have calculated dimension formula of B, but now we have also to calculate dimension formula of A. So now as dimension formula of pressure P, that is putting the dimension formula in this relation 1. So you will write dimension formula of pressure is ml minus 1 T minus 2. This will be equal to, numerator is x square minus b having formula L power 2. Denominator A is unknown and T is having formula T. So see here all the formulas we have substituted. Now unknown factor is A. So simply solve it by cross multiplying. You can see here now the mathematical calculation part is left. So now just rearrange the terms. This will be L2 in the denominator m, L minus 1, T minus 1. T raised to the power minus 2, T raised to the power 1. So it will be T raised to the power minus 1. Now arrange it in the numerator. So it will be m raised to the power minus 1, L raised to the power 2, minus minus plus, T raised to the power 1. So it comes out to be m minus 1, L3, T plus 1. Because here it is T raised to the power minus 1. So when it is coming in the numerator, it will be plus 1. So here you can see that what are the steps which we have used here. First of all, the relation. This relation is given to be correct. That's why they have asked only dimension formula of A and B. So the first step should be we must know the dimension formula of each term. Right? Then after this, as x square minus b, this must having the same dimension formula because only like quantities can be added or subtracted. So it is having formula L2. So dimension formula of b will be same. Now as per this equation, put the value of dimension formula of pressure x square minus b and time t. So on substituting here, you are getting dimension formula of A and it comes out to be m minus 1 L3 t plus 1. See, there may be the chances of mistakes in the calculation. So do it patiently. Don't just do the things in a rapid manner so that there can be the chances that you are not able to take my negative sign, minus plus sign properly. So this is our first numerical which we have done by using the concept of principle of homogeneity. Now coming to next numerical. See here statement is in van der Waals equation. This is an equation you will study in chemistry. We are simply using the result. P plus A by V square into V minus B equal to RB. So what are the dimensions of A and B? This A and B, where known quantities are P is pressure here, V is volume, R is gas constant and T is temperature. This all is given in the statement. Now the question is how to start. See, first of all, when you will just see the result, you will try to solve left hand side and right hand side together. But I will suggest you have nothing to do with the right hand side here. Don't get confused that the gas constant is there, temperature is there, so you have to use those values here. No, you have to simply use the result. Only like quantities can be added and like quantities can be subtracted. This which I have told you about this numerical, this all is its key point. Now how to start? As V is volume, so dimension formula of V, volume is L raised to the power 3. So dimension formula of V minus B, it must also be L3. Only like quantities can be subtracted, taking the result. Therefore, dimension formula of B, you can easily judge. Yes, it is L raised to the power 3. So this first portion we have solved. Now coming to this portion, again it is the sum of two like quantities as P is pressure here. So dimension formula of pressure we have already used in the previous numericals. So I am taking it directly. This is ml minus 1 T minus 2. Now dimension formula of P plus A by V square, it must also be same. Reason, only like quantities can be added. So what does it conclude? That dimension formula of A upon V square, it must be same as that of pressure. Now see, dimension formula of A upon V square, it is same as that of pressure. And V is volume, so you have to calculate dimension formula of A. So if you will take A upon V square, it has the dimension formula ml minus 1 T minus 2. V is volume, so V will be L3 raised to the power 2 ml minus 1 T minus 2. Now simple step, you have to just solve it. L raised to the power 6 in the denominator, m raised to the power L minus 1 T minus 2. Rearrange, cross multiplying, L raised to the power minus 1 T raised to the power minus 2 and L raised to the power 6. So what we are getting here, m L raised to the power 6 minus 1, it will be L raised to the power 5 and T raised to the power minus 2. So A will have dimension formula this, and B is having dimension formula L3. So you can see here that what we have done, we have given the statement that is the product of two terms, that is one is in the form of sum, another is in the form of difference. So when firstly we are taking any one term, V minus B we have taken, so calculating dimension formula of B, same as volume. And similarly for the other term, P plus A by V square, it must have the same dimension formula as that of pressure. So putting the dimension formula of volume, pressure and rearranging the terms, now you are getting dimension formula of A also. So this is about this numerical. Coming to next numerical. Here the statement, you have to understand it very carefully. Now in this statement one new concept of maths will be used, that is exponential function, which is represented by E. So let's read the statement first. The position of a particle at any time t is given by xt. It is equal to V naught upon alpha within the bracket 1 minus e raised to the power minus alpha t, where this V naught is any constant, alpha it is greater than 0. Now what are the dimensions of this V naught and alpha? You have to find dimension formula of V naught and alpha. So it's slightly different statement. You have never seen such kind of statement. Now see, first of all, this xt, you have to understand in maths you do sets functions where you will write that if y is a function of x, y is a function of x, then you will write it as fx. Let's see, if you are writing y is equal to x square plus 2x, you can write it as y is a function of x. Why? Because it is depending upon x parameter. Y is a function of x. Why? Because x is used in the vector, in the equation y. So this is independent and this is dependent. Y is depending on x. Similarly, as the statement is given xt, it means this is the equation which has been given to us within, first of all, x is a function of time. See here the term which is variable, that is it is depending upon time. So that's why we are taking it as xt. Basically x is a position, is a function of time. This is the meaning. Don't get confused that this is a multiplication. No. Left hand side x will be representing position only. It will not be position multiplied by time. This is a point to be noted. Just be careful about understanding this point. Coming directly to the numerical part. See here x is given to be this one. So x is equal to V naught by alpha 1 minus e raised to the power minus alpha t. Now what to do here? Now here you have to understand that first of all the power of e raised to the power minus alpha t is given, where e is some exponential function. So this e raised to the power minus alpha t, that is an exponential function. It must be dimensionless. Actually it is dimensionless. E, this is the term that you will use in one of your unit in maths this year in class 11. So don't get confused if you don't have maths, because the basic concept of maths which we will use in the physics I will explain one by one wherever it will be required. So you have to learn one thing, that exponential function must be dimensionless. It will be possible that when it can be written as 1 by e raised to the power alpha t, this is also dimensionless. It means alpha t is also dimensionless. You can write it as 1. Dimensionless means no dimension. So now put the dimension formula of t. So alpha is having dimension formula. This will be 1 by t, which I can write as t raised to the power minus 1. Now, on the left hand side, in the statement part, this is 1 minus e raised to the power minus alpha t. One another point you can understand why this is dimensionless in a simple way. This is a difference of two like terms. One is a constant, so this term must also be a constant. You can relate it like this. This should also be dimensionless. So that's why we have taken this to be dimensionless and hence calculated the dimension of alpha. So now 1 minus e raised to the power minus alpha t is dimensionless. So no contribution to dimension. So what is left on the right hand side? V naught by alpha. Dimensionally 1 minus e raised to the power minus alpha t, that is dimensionless. So now this V naught upon alpha, this must have dimension of length. Why? Coming to the statement again, you can see here x, you will take dimension of distance only. This 1 minus e raised to the power minus alpha t dimensionless. So V naught upon alpha must have dimension formula L. Now substitute the dimension formula of alpha. This is t minus 1. So V naught will have dimension formula LT minus 1. See, this second step is quite simple. What you have to understand, this exponential concept. As it has been clearly indicated that 1 minus e raised to the power minus alpha t is given here. So directly you can take that 1 minus e raised to the power minus alpha t. This completely should be dimensionless. So if it is dimensionless, e raised to the power minus alpha t should be dimensionless. So if it is so, then alpha t, this power should also be dimensionless. Power dimensionless, that is a main step you have done till now. If you have understood this point, I hope you will not be able to have any problem in this numerical. You will be able to solve this numerical. So alpha t will be 1, alpha will be t minus 1, and then you have calculated this V naught dimensions. Now coming to next numerical, here in relation P equal to A upon B, e raised to the power minus AZ upon theta, where P is pressure, Z is distance, theta is temperature. What is the dimensional formula of A and B? See, here in this equation, in this relation, P pressure, Z distance, theta temperature. So unknown are A and B. Now, how to proceed it? As we have done in the previous numerical, that exponential function is used here, and as we know that exponential function is dimensionless. So e raised to the power minus AZ upon theta, it is dimensionless. So when it is dimensionless, its power, you can take it in this form, AZ is also dimensionless, or you can take its power, this is AZ upon theta, this must be dimensionless. A is unknown, Z is distance, theta temperature. See here temperature is used first time in the formula. Before it you have done in one assignment, that is the formula for gas constant, where you have used this K. So here this A will have dimension formula AL equal to K. So A is K upon L, that is KL minus 1. Simply by using exponential to be dimensionless and power should be dimensionless, you have calculated dimension formula of A. Now, as in the statement A upon B, now multiplied by exponential function, this exponential function is dimensionless. So what is left? A upon B, out of which we have calculated dimension formula of A. So it means A upon B must have dimension formula as that of pressure, and pressure is having dimension formula ml minus 1 T minus 2. So now A, you will substitute the dimension formula of A here, K L minus 1 upon, just cross multiplying simultaneously, M L minus 1 T minus 2 and B in the numerator. See what we have done? Just we have taken this term in the denominator and B in the numerator to directly to calculate dimension formula of B. So from here, what you are getting? This M is in the denominator. It will come out to be M raised to the power minus 1. L raised to the power minus 1 in the numerator and raised to the power minus 1 in the denominator. So L raised to the power 0. T raised to the power minus 2. So in the numerator, T raised to the power 2. And K raised to the power 1. So this is the dimension formula of B and this is the dimension formula of A. Here in this kind of numerical, just you have to understand that exponential function are dimensionless. This is a key point which you have to apply wherever you will use the concept of exponential function. Now after this, coming to the next statement, next numerical. Write the dimension formula of omega and K also I am taking from the following relation, where y is equal to a sine omega t minus kx. See, this is a relation. If you remember, such kind of relation we have used in checking the correctness of physical relation. So here sometimes specifications are not specified because y simply is displacement, a is amplitude, t is time and x is distance. So many times in this kind of numericals, these basic specifications will not be given here. So here, how to proceed? The basic step is this sine function should be dimensionless. When it is dimensionless, it means omega t minus kx, it must be dimensionless. If it is dimensionless, what does it mean? That omega t minus kx, it is having no dimension formula. Or you can say only like quantities can be subtracted. It means each of this product, omega t is dimensionless, kt, it is also dimensionless. So you can take it as omega t is 1, which is equal to kx. Why? Because both will have same dimension formula, as both are dimensionless. Now omega t equal to 1. So omega t having formula capital T. So what is the dimension formula of omega? It will be t minus 1. Then you will take it in the denominator and writing in the next step, it will be same. Omega t 1, omega into dimension formula of t to be 1, taking it in the right hand side, and hence you are getting this. Similarly, kx should also be having dimension formula 1, that is having no dimensions. So k dimension formula of x is L. So k will be 1 upon L, or you can directly take it as L minus 1. So in this way you have calculated dimension formula of omega and k. In the statement k is given, so we have calculated dimension formula of both omega and k. What we have used here, that the angle in this relation, this angle should be dimensionless. So each of the two terms whose difference is taken, that also must be dimensionless. Now, next numerical is calculate x in equation velocity raised to the power x equal to pressure difference raised to the power 3 by 2 and density raised to the power minus 3 by 2. So here we have to calculate the value of x, which is a power of velocity. So what to do in this numerical? Simply you will use the concept of dimensional formula, substitute dimension formula of each term used in the relation. See, left hand side is velocity, so dimension formula of velocity is Lt minus 1. on the right hand side, here it is pressure difference, and pressure is having formula m L minus 1 T minus 2 raised to the power, this is 3 by 2. Now density, mass per unit volume, m L minus 3 raised to the power minus 3 by 2. This is a step. Now in the next step, what you have to do, simply rearrange the powers of m, L, T on right hand side and compare. As on the right hand side, m raised to the power 3 by 2 here and minus 3 by 2. L raised to the power, this is minus 3 by 2, and minus minus plus, this will be 9 by 2. 3 into 3, 9. And T raised to the power minus 2, 3 by 2. 2 will be cancelled. You are getting minus 3. So m raised to the power 0, L raised to the power 6 by 2. When you will take its LCM, T raised to the power minus 3. So m raised to the power 0, 1, L raised to the power 3, T raised to the power minus 3. You can also write it as LT minus 1 raised to the power 3. You can proceed it in the bracket or as such. So here on the left hand side, it is LT minus 1 raised to the power x. So now on comparing left side, right side, its base is same. So x is, yes, it is 3. So now all the questions we have discussed on these kinds, now there will be more different practice. Basically the statement will change. You have to apply the concepts we have done. Now today we are not giving you any other concept. I am just taking the previous concepts of formulas and then able to solve the numericals. You have to proceed in the similar way. Coming to next numerical. Find the value of x in relation y equal to t raised to the power x cos theta tau divided by L cube, where y is Young modulus of elasticity, stress upon strain, modulus of elasticity, coefficient of elasticity you have taken, t time period, L length, and torque. So here what you have to do, you have to find the value of x power. Power is there. So you will rearrange the terms. Here theta, cos theta is trigonometric function, that is angle, and angle is dimensionless. So what should we do here from this equation? If we calculate the value of t raised to the power x by cross multiplying, you will get y L cube upon tau cos theta. Now, what should be the next step? It will be substituting the dimension formula. Y, Young modulus, stress upon strain, strain is dimensionless, stress having same formula as that of pressure. So this way you can relate. So Y will have dimension formula ml minus 1, T minus 2. L, it is having dimension formula L, so L3. As such we are taking. Torque is basically having same formula as that of work, and work is force into distance, so it will be ml2 T minus 2. And cos theta is dimensionless. So in the next step, rearrange the terms. M raised to the power 0, L raised to the power minus 1 plus 3 minus 2 from the denominator. I am taking it in a simplified manner so that you will not be confused. T raised to the power minus 2 in the numerator and minus plus from the denominator. So you are getting m raised to the power 0, L raised to the power 0, T raised to the power 0. So now you can write it as T raised to the power 0, because although all the terms are giving value 1, But left hand side is expressed as t raised to the power x. So right hand side should also be expressed in a similar manner. So now you can compare and get value of x. This will be 0. So there is nothing new concept. Simply substitution of dimension formulas and solving it. Now next numerical. The number of particles given by n, that is small n is given here, equal to minus d, capital D, multiplied by n2 minus n1 divided by x2 minus x1. See, the number of particles given by this relation are crossing a unit area perpendicular to x-axis in a unit time, where n1 and n2 are number of particles per unit volume for the value of x meant to be x1 and x2. What is the dimensional formula of diffusion constant D? So in the relation you have to find dimension formula of D. So first of all, the basic concept here is to understand the statement. If you got the clarity of what is given in the statement, then the problem is simplified. See here, particles, number of particles n. So here it has been given n equal to minus d n2 minus n1 upon x2 minus x1. Now you can just see the statement, you can just learn the statement that the particles are crossing per unit area perpendicular to axis per unit time. So basically n is representing, these are the particles crossing per unit area per unit time. So here diffusion constant will be, rearrange the term, n into x2 minus x1 upon n2 minus n1. Negative sign you can drop. Here we have to simply use the dimensional formula, no significance of negative sign here. Now dimension formula of n. See, crossing a unit area in unit time means particles are crossing per unit area per unit time. Per unit area per unit time means, see, number of particles crossing per unit area per unit time. So number of particles, that is simply a constant, no dimension formula. If you will take its formula, this is this one, so it will be minus 2 L raised to the power minus 2 T raised to the power minus 1. So directly I have taken the formula. Number of particles in unit area in unit time means per unit area per unit time. This is the hidden concept in the statement. So now after this, dimensional formula of n. Now what is given about n1 and n2? Here n1 and n2 are the number of particles crossing per unit volume. Number of particles per unit volume. As we have calculated dimension formula of n. So here number of particles is constant per unit volume. That will contribute to dimension formula. So dimension formula of n1 and n2, it will be L raised to the power minus 3. And x1 and x2, we all know this is only the length. Now, yes, what you have to do, you have to substitute the value in diffusion constant D. So put the value, substitute it, and that is L raised to the power minus 2, T raised to the power minus 1. Then x, L minus L, it will be the dimension formula. N2 minus N1, L raised to the power minus 3. So now solve it. Numerator, L raised to the power minus 2 plus 1, T raised to the power minus 1, L raised to the power 3 I have taken in the numerator. So it will be L raised to the power minus 1 plus 3, T raised to the power minus 1. Yes, L raised to the power 2, T raised to the power minus 1. So this is the dimension formula of diffusion constant. Usually this kind of problem we give for practice for the students, but slight concept is different, so you should not be confused. That's why I have explained this concept to you, numerical to you. That's all for the day. So we have covered today few numericals on the concept of principle of homogeneity. So I have covered all kind of numericals of dimensional analysis. Now it's your work. You have to practice all the questions by writing. Just don't give a oral practice. Don't just look at the notes and just you have done the practice. No, give it a written practice. Otherwise, you will not get confident on numericals, as numericals are the backbone of physics. Without numericals, physics cannot be done. So, I advise you to revise all the numericals concepts thoroughly by written practice. Thank you. Have a nice day.